Hello, in this video I make a follow-up for the subdivision themes here. And in previous video I just collapsed this object curve section here. But let's explore what here is and what are those commented out sections here. And we just first off start up this application here, and I open up a pre-arranged scene. I get this fuller an object here. And I rank up the subdivision, so we can see those curves having effect on this object. And when we go into curve mode, then we see those curves here. And what we need to explore, I press Alt P and we explore this shape here. And with this Fullerene or soccer ball geometry, there are two types of polygons there. One type is pentagons and another type is hexagons. And what about those types? Pentagons have uneven number of poly edges, since hexagons have even number of poly edges as of also quadrants. And we need to handle those even and uneven cases differently. And what we need to observe here is this really this slant here, what goes along this border, and the various features here. We need to make sure that it is essentially same shape if we're going to change the code here right now. And we need to observe this shape. Right now I close this up, and let's take a look at the code here. In the previous video I collapsed this curves case here. This one was collapsed, and now we're going to expand it. And what we need to know about it is that we get those polycenters and polyvectors initialized to 0 first off, and then we populate those variables in the next sections. But what about those uneven and even edges polys? Here we see that we claim V patch, and we have this loop of edge counts commented out if uneven, and it works. But let's take a look further down here. Here it also claims this uneven and even case, and this is about those polycenters. And we see that if it's uneven, that meaning the previously commented out, then it takes a different approach, and this approach is essentially a vector normal of this polycenter. Let's imagine that we have a polygon that has curves to do edges opposite to each other, and those edges are sort of not normal related, but they sort of skewed in the one direction. Then we should assume that the polycenter also gets displaced in the same direction, we need to use this displacement vector of those edges or curved edges. And we see here that we don't use this vector right now, we use this normal vector, this vertex normal gets multiplied and added to the original location, this tx, ty, dc, and multiplied by the distance that is pre-calculated. And we could avoid this. It's maybe faster, maybe not, I don't know, but we could do it this way. Just delete this section here, delete this square bracket remnant, then we correct those indentations, and then we go up here and we just uncomment this section here. And this way we get this uneven case also based on the polyvector. And let's compile it. Now it claims that one warning is present. This is the unnecessary variable declaration, but let's leave it that way. And I just run this program again, and I open up the same file, space, and I load it up and press page up several times. And we see this shape here in the new evaluation of the patches. And Alt P, we see those in the patch mode, and it looks the same. Essentially, this means that if we got those variable patches here, that the result is the same essentially. Maybe it's a little bit slower, I don't know exactly, but we see here. And I just wish to manipulate one of the vertices here. If it's something else, we see that the code is not slower, it's almost the same speed, I guess. Of course, this is for level 1, and we need to check out what happens in the next subdivision function here. And if we have something similar here applied. Let's scroll this one here. If I can find it, I'm not sure. Here the section of curve count begins, and it has a restriction to the subdivision levels also, but this restriction is because of with further subdivisions essentially the whole systems need to be rewritten because it has not the real patches but only patch indications for the polycenter vertices and patch indications for the edge center vertices or edges. And let's take a look if we got this uneven case here also, maybe somewhere. Right now I don't notice any commented out sections here. But this is for further investigation. Of course, the first subdivision level is more pronounced because it sets the bounds and rules for the other subdivision levels.